Can't. Now I'm gonna do the exact same thing in a second. I'm gonna put my fingers up. Ooh.
That's a 3.
4.
Trick question. I gave you 0. All right. So if you can't see around corners, then light cannot be a wave. It acts like a particle. You can see the light on the floor, right? If I throw a tennis ball from the hallway where the light is, it's going to hit where the light is, on the wall. It's a particle. It's going to bounce off. If you want to, put a mirror up. You'll see it bouncing off the mirror. It bounces.
That's dangerous.
Now, sound echoes, but it echoes and spreads out. And so if I had a puddle of water on the floor and I'm jumping up and down the hallway, you'd all know how hard I was jumping, and you'd all know how often I was jumping. Waves travel around corners. It happens. Right?
Yes.
Okay. And then there's a single slit where I showed, might as well do it. We got a little time today, we're good. Don't look backwards.
Oh, it's too much.
Okay, I'm going to say don't look back at the count to 20, so I'll do like a done looking backwards. Don't look backwards. Larson, a $2 laser will bother you. It's actually a $700 laser I bought in the 70s, which looks just like the kind you buy at the grocery store now. So there's my laser. It's right there on the wall. It makes a dot. You can't make a dot with sound. I can talk any way I want to. I cannot make a dot on the wall. They cannot make it so one person hears me and nobody else does. Even with a whole bunch of lenses, it doesn't work. It spreads out. There's nothing you can do. Waves have to spread out. They have that property where they move out from that spot. And then I made the argument. I don't have a worksheet in front of me. I do have it right here. Okay. And then we had the final, most devastating argument, which is, what is in space?
Light.
Nothing. How am I shaking nothing? You're a believe in waves, media. How can you shake nothing? The answer to the question, you can't shake nothing, so therefore, if there's nothing in space, there can be no waves.
Okay.
It's a particle.
What's wrong with that?
Heat can't travel through space, according to the same people. At least not the infrared version. You would be a good person to make that argument. You could go, hey, wait a second. Are we getting our heat from the sun? No! Because the particles, those particles are striking the earth and warming us as they strike the earth. It's friction. Then the other side of the argument was the wave argument. Yes, you can't see around corners, but you can certainly... Did anybody go in the bathroom and close the door and turn a light outside but not a light inside? Did you? Look right next. I'm telling you, when you close the door, you turn out the light in the dark room, you'll see light right on the door jamb on this side. What's lighting that? It's a particle, and if it gets to the door jamb, it's going that way, right? Why is it spreading out along the wall? It doesn't go far, but it does spread out.
Wow.
And then I showed you the double slit.
Wait, what?
The double slit, and you guys didn't understand the double slit, but I'll show you the double slit one more time, and then I'll show you a double slit but built by somebody else, but this is an important issue.
Oh.
So I put the slits in my glasses. Now you guys saw the laser before. The laser made a single dot on the wall. I'll make the dot again. There's the dot. See the dot?
Yes.
Now if I put slits in front of it, if it's particles, then I should just have a bunch of dots on the wall, but I should not have it spreading out at all, right? Why would it spread out? But throwing tennis balls through slats in the fence, it just goes straight, wouldn't they? Yeah. But if I do this, all of a sudden I have one dot. Why do I have one dot? Okay, they're all there. You just can't find them. There they are. Dots, 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 dots. Got lots of dots. And they're repeating. And so that's more like the following. Now, for this, I did take, Eppolito says she's never seen waves at a lake, so I thought I'd just show her what water looks like when it makes waves. So here you go. So I have this nice video right here, and it's going to show me a nice diffraction. Oh, so I'm going to hit, I didn't mean to do that. Okay, here we go. So here it is, spreading out. Now, waves being made, strike two holes. What happens as the water gets there?
So much. Oh, really?
Now, I'm going to pause here. Notice how it's making places where it's bright. Okay, I'm going to keep going. right? If particles don't do that, right?
That's pretty.
Particles are not going to make a bunch of dots here. Instead, particles are going to go right to the slots and make 2 spots. They're going to hit the back. Instead, this has a bunch of them coming across. Let's see if I can get just a little farther without it stopping on me. Okay, so they're saying high point, high point, high points. This is where all the high points are striking. Okay? And so you see where the high points are. It's spreading out. So that happens with waves, but doesn't happen with particles. I put a bunch of slats in front of that laser. All of a sudden, I got lots of dots. So it's acting like a what? A wave. And so that's a problem. Now, the last one is the most darting evidence of all. And in fact, on the floor, what spurred the fight between particles and waves was one guy walking around with polarized lenses. You're like, polarized lenses, why does he fight? Because he was too cool for the other ones. No, that wasn't it. You know, physicists don't fight over who's the coolest person in the room. Seldom they fight over that. So I'm going to put 2 lenses on the table. I don't want you to touch them until I give you some instructions. Because I find that if you play with them first, you're like, I don't get this. Whereas if you don't play with them first, you get it easily. It's a piece of cake.
Don't touch it.
Well, I'm not gonna do anything with it too. I'm just
Okay, here we go. I got 2 right here. All
Sorry,
right.
Carolyn.
Touch the lens.
Sorry, but you would like to.
Touch them right away. Make sure you touch them right away. I'm just kidding. Don't touch them right
It's
away.
inhibiting the lab experience.
Good.
Perfect.
Excellent.
I'm not fun.
Excellent. Here we go.
I'm not.
All right. You got me? Okay, good. Right. And so here's.
Poor favor.
I only
All right, you can have
we
those
don't
two.
have pink.
Okay, I'm gonna get the pink ones because they're cooler. Mommy! Where do I get my polarized lenses from?
That's fierce, that's fierce. Oh my god, you steal?
Hey, I don't steal. They say, we would like to appreciate you put them in the bin for other people to recycle. And I say, I'm not recycling, I'm reusing, which is a higher order of recycling.
You're an environmentalist.
No, I'm an environmentalist. I'm saving the universe by
Kill
taking
those
the
names.
plastics. So what I want you to do is this. I want you to pick a light in this room. Let me turn on the ones in the front.
Can we touch them?
I want you to point it at one of the lights in the room. And I want you to take the 2 lenses, and I want you to cover each other. So you're looking through the 2 lenses like that.
Okay, cool, Taylor, go first.
You need 2 lenses, 1 person looking through them. Let's go. You
Yeah.
can figure this out in a second.
Here, tell you.
Okay, now look at the light with them. Look at them. Straight at the light. Straight at the light. Straight at the light. Straight at the light. Most of you are aimed at a light. That's weird. Okay, so now I want you to turn one of the lenses, just one of them, 90 degrees.
What in the world?
Turn one of them 90 degrees, and then turn it back. One of them 90 degrees, turn it back. Turn it. Oh, the lights. The universe is going dark. What is going on here? Ah! Ah! Ah!
So cool.
Science is great.
That's weird. Why is this?
Is this how they do? Like, have you ever been on one of those? Some planes have windows that just
Oh, really? Hear that?
darken. You just
Usually that's a chemical. Usually a chemical in there that's photosensitive.
No. You can like turn a dial or like flip the thing and just darken.
That would be probably a CD. That's like crystal display, like on your calculator.
What the heck?
usually.
That's still.
Now, what's interesting though is if you want to get your calculator, put a number in there, and then play with your polarized lens with that too. That's get some weird stuff going on. I don't know if yours is going to work that way.
Okay, cool.
Is that why it's kind of funky?
The one that looked like this. Now look at it. No, which one lens? Now turn it. Now turn it. No. Give me that. Give me that. Pick one. Okay. Now look at it. Now turn it.
Just that?
Yeah. It should do something weird.
What does it do?
It disappears.
Okay? Because your calculator has polarized light, unless you got one of those cheap TI ones. I don't know.
It's fine. I'll just
Whatever
play
you
with
do to
the
help.
light. I don't even know.
Resney, why is it playing?
Just one lens, lad.
That's so weird.
Working, but it's only blocking when it's only.
Wait, what's cool about it?
Yeah, that's what I'm saying.
Only one showing.
Oh, that means one of either the lens is whacked or the screen is whacked. One of
It's
the two.
not exactly 90.
It's probably my lenses. So my lenses, I get them as cheap as I can. Whenever I see some child walking down the street with a polarized lens, I knock them down and take their stuff. You don't get good quality that way. All right.
What is it?
So what's happening is this. What a polarized lens is, and this is an extraordinarily crude way to say it, but I'm going to say it that way anyway, so because we'll understand. And by the way, this is the way they're first made, so I'm not really being completely crude. And that is, it's just a bunch of lines this way. Right? And so if I take one lens like this, if it's a particle, it passes right through it and some would bounce off, right? If it's not a particle, it's a wave, and some would get through, and some would be blocked. So one lens doesn't mean diddly squat. But if I put up two, and I put them the same way, then they would act the same way. Some particles get through, bounce off, some do not. But what happens when I do this?
Cross.
Well, a wave, since it's transverse, it can't get through the holes. Right? It can get, the ones that are going this way get to the first layer, but when it hits the second layer, they're blocked. And so you create a situation by which there's no way for one to get through. Okay? A particle, if it's thin enough to stop it, it's thin enough to stop it even just one. And yet this doesn't stop it. One does not stop it. Two does, which means it has a width but not a length, which is really odd unless you're talking about a transverse wave. And so therefore, the argument was laid out. Which is it? Because I've just given you a perfectly rational argument why it's got to be both. But Mr. Leoncio,
Why can't it be?
what's the problem with it being? What's the problem with my arguments? Well, the arguments are all solid evidence for both cases, right? It's either a wave or a particle. And the answer to the question is, that's weird. And so people were fighting. This was actual people going to hospitals over this. Because you just called it a wave. That's it. I've had it with you. I'm tired of talking to you. I'm going to knock you down and take your stuff now. Take away your stupid lens things, because it doesn't prove anything. Now, Albert Einstein is given tremendous credit for being a genius.
How does he literally
He
do
is.
everything?
He's considered a tremendous genius for being, but he just said exactly what Ippolito said like a minute ago.
Oh my god,
I
you
believe
just
it's
told me Einstein.
Einstein.
Okay? All that Einstein said was this. He said, well, if it's got to be a particle and it's got to be a wave, yeah. Okay. Done. I agree with both camps. Good job. Let me go home now. And they're like, no, you don't understand. It's got to be one or the other. No, it can be both. And this is how it can be both.
So you thought.
Imagine for a moment I have a single wavelength of light. We're going to call it
Jim.
a photon. If I do, it would be incredibly small. It would be incredibly small. And that wave being incredibly small would most times act like a particle. It would travel in a straight line. It's not interacting with it. It would travel like that. But if it gets on the very edge of a doorway, where it could run into the sides, where it runs into interference, it would then spread out like a wave should. Yeah? It can't get through the polarites because it does have wave properties. It can be singularly collimated because there are individual particles coming out. I can point that on a wall. But if I put a slit in front of it, now it's interacting as if it's waves. It acts like little bitty waves.
So
And it can interact with the people around it,
so
with the other ways around it.
it's a particle with wave properties?
It's a wave with particle properties or a particle with wave properties. You can pick either way. It is both. It is both. And we call it a photon. It's a single wavelength of incredibly small, usually light.
But so is that why when it does the thing where it spreads out just past the door? Because each individual wavelength spreads out, not the whole wave.
Right. Only one little wave is going to be right against that wall, against the door. It's going to spread around that corner, and it will spread around that corner and light that side. But if it's not right next to the door jamb, it's going to miss it altogether. It's going to go a straight line and act like a particle. That answers 90% of what we just said. There's one argument that this does not solve, and that is what?
How light is made.
Oh, we got to do how light is made in a moment. But what's one argument on that list? There's one argument.